today's lesson, we are going to be learning about fractions, and not just any old fractions. We're going to be learning about equivalent fractions. Our goal for today is to teach you how to use equivalent fractions to add and subtract. And along with this lesson, there is a very, very, very important link that you're going to need to open up so that you can be answering the questions during the lesson. The link is also in the Google or in the YouTube description, so feel free to take a moment to pause this video and copy the link and paste it and have it open in another tab. This leads us to our first form question. This question is labeled question number 1 on the Google form, and the question states, what do you know about fractions? Use pictures, numbers, and words to explain your thoughts. You are also allowed to use the sheet in front of you that also has the same question labels on it to draw some pictures since you can't draw pictures on the Google form. Feel free to take a moment to pause the video and answer this question. First, what is an equivalent fraction? Equivalent fractions are essentially what they sound like. They are two or more fractions that, although use different numbers, represent the exact same thing. And why are they important? They're important because in order to add and subtract fractions, you must have a common denominator. Now, what is a common denominator? You may or may not know, but in case you do not know or may have forgotten, we will go over what a common denominator is in the next slide. Our first fraction review is going to cover numerators and denominators. This leads us to our second form question. What do you know about numerators and denominators of a fraction? Use the form to explain what you know, and again, also use the paper to draw anything to help explain your thinking. Again, pause the video and take a moment to answer this question. Now, to go over numerators and denominators, I'm first going to write a fraction. Let's say 3/4. Now, the denominator is always the bottom number. And numerator is always the top number. And the denominator I like to think of as the whole. And the numerator as a part of the whole, or how many parts of the whole are being taken up. Now, we're going to kind of look at another way that we can represent this so I can show what I mean when I say the denominator is a whole and the numerator is the part. Keeping the same fraction, I'm going to erase these words and I'm going to draw a picture. Now, this picture, I'm going to use a pie. There are several ways that you can show this, but this is one that helps me understand it. I'm going to divide this pie, which is one whole pie, into 4 pieces. And that's where the 4 comes from in the denominator. So there are 1, 2, 3, 4 pieces in the whole. Now, this fraction says that there are 3/4, which means we have 1, 2, 3 of the 4 pieces. So the numerator is 3 and the denominator is 4. So 3 parts of the 4 total pieces. The next idea that I would like to review before we go over the lesson is about fraction representations. This leads us to a third form question. What are some different ways to represent a fraction? Show any fraction in as many ways as possible. Try to use words, pictures, and numbers. Use the form and the sheet in front of you. Take a few minutes to try to come up with a couple ways that you can represent either the same fraction or several different fractions. Okay, I'm going to show you a few ways that I represent fractions. For my example, I'm going to use 1/4 the whole time. So this is the first way that I think about writing a fraction, 1/4. I also see it written like this sometimes, especially when you're typing. Those are both numerical representations of fractions. Next, I will show you a pictorial or a picture representation of a fraction. Like I showed earlier, I used a pie. You can divide a pie up into 4 parts, or maybe 8 parts. You can probably divide it up to a whole 100 parts, probably. Or you can use a bar chart or a bar to show. You could use even a triangle. You could divide it maybe like this to show 4 parts. You show 1/4 here, or 1/4 here, or even 1/4 here. Alright, and the next way that I'm going to show is using words. So we could say 1/4 or 1/4. Now there are several ways that you can do this, and everybody does it different. Throughout this lesson, I'm going to show you a couple ways, but feel free to still use the way that you understand best, or even use the way that your friend or your partner is using. Now, after we've reviewed some key ideas about fractions, we're going to move on to our first question. Abe has 3/8 of a cookie, and Sammy has 1/2 of a cookie. Abe says, "Wow, we only have 3/16 of a cookie altogether." Sammy says, "No, Abe, we have 7/8 of a cookie." Now this leads us to our fourth form question. Who is correct? Are they both right? Explain using words, pictures, and numbers on the Google form and or the sheet in front of you. Take a few minutes to conversate with the person who you're working with and come up with your answer. And once you're finished, continue on to the lesson. Now, before we talk about who is correct in the problem, let's talk more about equivalent fractions. So let's start with the fraction 1/2. In order to change this fraction, let's look at this pie chart first. We have 1/2. Now, can we divide this pie up even more and change the fraction? I'm thinking we could take this pie, divide it into half again, and what do you notice when I divide it like this? Now talk with your partner, and then this leads us to form question number 5. What do you think about what just happened? Does the fraction change? Take a moment to respond to this question on the Google form with your partner. Okay, so next we are going to look back here. Now, I believe that this fraction right here is the same as the one right here that we originally made. But it's almost interesting because I see 1, 2, 3, 4 pieces now. And 2 of them are filled. So we just changed this fraction 1/2 into 2/4, but it's still the same. And this right here is an equivalent fraction. Now here I wrote again the 2 fractions that we found out were equivalent. Next, let's see, actually I'm going to write equal sign here because we know that these 2 are equal to each other. Now one pattern that I noticed that we could continue are these pie charts right here. So I say we draw another one and divide it up even more. If we divide it up equally, again like this, and shade this in, think about what that fraction would be. I count 1, 2, 3, 4 pieces out of 5, 6, 7, 8. So 4/8. Another pattern that I see within these numbers is that I'm taking 1 times 2 to get 2. I'm also taking 2 times 2 to get 4. And again, I am also taking 2 times 2 to get 4, and then 4 times 2 to get 8. So I think that we just came up with a new rule. And that rule is to multiply the numerator and the denominator by the same number to find an equivalent fraction. So 1/2 is equal to 2/4 because we multiplied both the numerator and the denominator by the same number. So 1/2 is equal to 2/4, which is also equal to 4/8, and so on. Now, with that information, we're going to head back to the original problem that we were working on. And that problem is 3/8 plus 1/2 equals question mark. So let's see if we can use our new knowledge about equivalent fractions to help us solve this problem. So I'm going to say 3/8 plus 1/2 equals question mark. Okay, so now I'm going to draw my pie chart and I'm going to divide it into 8ths. See, now we have 8 equal pieces, or just about equal. And I'm going to shade in 3 of those. Okay, now I'm going to add that to 1/2. I'm sorry about that. That's more of an oval than a circle. But I can still see that there is half there. Now, originally, I could draw it like this. I'd say, well, there's my half, and, oh, I'm not sure how I can put my 8ths in there. I mean, I could probably guess, but I don't even know how I'd write that. So, what I could do is shade in my half, and then I could divide it into 8ths so that I can add those 3/8, because 1/2 can be multiplied to make the denominator 8. And what could that be? Let's see. 1/2 times what could get to 8ths? Let's say times 4. So now we have 4/8. So we know that the 1, 2, 3, 4/8 there are representing the half, and then we can add the 3/8. So now, how many 8ths do we have filled? That's right, we have 7/8. And which of the two people in our earlier problems said that the answer was 7/8? Yep, that's right, it was Sammy. Alright, so with our new information and our new solving methods, let's see if we can answer a few more questions about equivalent fractions on our Google form. The next question on the Google form is, what is 5/8 plus 2/4? Can we make these numbers have a common denominator? Answer any way you like best. And what I mean by that is you need to record your answers on the Google form, but you feel free to use the paper in front of you to solve it however you like. And remember, you do not need to use the pie charts or numbers to help you solve, but those are just a few ways to help you understand. Once you have finished solving your problem, please push play and continue through the presentation. Now let's see if we can solve 5/8 plus 2/4 together. Now, the one way we could do this is with our pie charts. Actually, let's not use a pie chart. Let's try something different. Let's see if I can use a bar. So I'm going to divide this bar into 8ths as best as I can. And then seeing if I can write a very similar bar here. I'm going to erase this. But instead into 4ths. So I see that I have 1, 2, 3, 4, 5 8ths. And one marker that I can look at is right here, which is 4/8, and that's our half mark. So here, another thing we can point out right here is our half mark and show 2/4. Now, one thing I would like to do is make this so that we have a common denominator or the same amount of pieces in each bar. So I would like to use our final bar with 8 pieces. So let's see